All right, good afternoon. This is Adam Smirkin. I'm joined with Peter Epstein, and we are speaking with NOV.V, Nicole Blanchard, and their advisor to the company, Mr. Jack Lifton. Jack, how are you doing?
I'm fine, thank you.
Great. So today we're speaking about NOV.V, the company. It's come a long way. It's finally about to go into construction. Just the financing's taking place to get everything going, and you just joined the company. You become more involved in being an advisor. What attracted you to NOV.V?
It's the next stage in recycling technology. It's vastly simplified, much cleaner and sustainable, much more so than the current processes used in recycling the platinum group metals. There's no comparison.
Mm-hmm. And so could you please give me and others a simplified idea of the NOV.V process that a simple mind like mine can understand?
Okay. The NOV.V process basically volatilizes the platinum group metals as chemical compounds in the form of a gas, so that, and this occurs at very low temperatures and ordinary pressures, so that by just placing the material in the flow of the reactant gases that are used to cause this, you're literally blowing the platinum group metals off of the scrap that they're contained in,
Mm-hmm.
and then you capture them in a water solution. It's not just water, but it's a mild acid solution, and then from there you process them. Now, this is compared to putting the scrap into the chamber of a smelter with molten copper, nickel, iron, or lead, and literally boiling those metals so that they will wash the scrap and slowly dissolve the platinum, palladium, rhodium off of the scrap. This takes hours and hours at very high temperatures, at very dangerous conditions with a lot of toxic gases. This is how it's done. It's been done like this for most of the 20th century and now the 21st. It can't continue because it is energy intensive, expensive, and polluting. But it's the only way we currently recover these metals from scrap. And these metals are critical. We cannot make cars without them, for example.
Yeah.
So the NOV.V process is really a step forward. I won't say it's magic, not at all. It's the evolution of chemistry. It's applying technologies that were developed over the last 50 years to the extraction of platinum metals from the scrap. It works very nicely. It's much, much cleaner and cheaper. And by the way, more efficient than the old process, much more efficient. And these metals cannot be lost. So we recover more of them from the scrap using this relatively simple process than we do with the horrendous cauldrons of molten metal that are used now.
Mm-hmm. No, I like that, how you describe it as like an evolution of the smelting. Now, and you brought up an important point. Currently, demand is outstripping the PGM supplies, especially for the past 7 years. Deficit's been getting bigger and bigger. And with PGM deposits in so few and diminishing, will the world have to turn to urban mining, recycling?
Yes. In fact, the Western world, let's say that if we talk from the Urals to the Pacific Ocean off California, there's about 700 million people. In the world, there's 7 billion people. We 700 million have been using this stuff as if, we're the only customer. What's happening now in the 21st century is the rest of the world is catching up. China, for example, as you know, is an economic dynamo. China, in the next 12 months, will make 24 million cars. This is more than Europe, all of Europe produces, and it's about 50% more than the United States is producing. China is now mandating a catalytic converter on every car. So we are now adding a huge number of vehicles that each demand 2 or 3 grams of platinum, a fraction of a gram of rhodium, 2 or 3 grams of palladium. There simply isn't enough of it. Mm-hmm. So we need to conserve it by never wasting it. That means when a catalytic converter on a car is run its lifetime, you need to recover the platinum group metals and use them again. It's not. I'm not saying there's peak platinum or peak rhodium, but the fact is, you just mentioned it. It's very expensive to mine platinum. It occurs in extremely low grades. A couple of hundred parts per million is considered a good platinum grade in an ore. The amount of energy to recover these things from the ore is dramatic. You do not want to repeat that. In scrap, all of the energy used to extract the metals from the earth and refine them has already been used. Hey, you don't want to do that again. So the amount of energy to recover platinum group metals from scrap is much, much, much less than required to recover it from the raw ore. So this is a situation where the manufacturing community of the world has figured out that recycling is a necessity. It's not just a hobby. It's a part of the supply chain now, a considerable part of their supply chain. Mm-hmm. And we can't do without it. We need to lower the cost and increase the efficiency. That's exactly what NOV.V is doing. Lowering the cost of recovering these materials and increasing the efficiency of recovery. Mm-hmm. You can't compete on this.
Yeah, no, I like how you brought up obviously China is the all the demand for cars in the future coming from the emerging markets.
And keep in mind, mm-hmm. China produces no platinum group metal whatsoever from mines.
Mm-hmm. They just made a recent the state-owned mining company just made a bid for Ivanhoe Mines platinum deposit, and I think that's a strong indicator that they're trying to get their future supply taken care of, especially on these materials.
The Chinese are coming. Mm-hmm. Let's say that in the last 2 or 3 years, I have seen over and again Chinese mining companies mm-hmm. bidding on non-Chinese deposits, non-Chinese companies. Even when I say deposits, the unusual part about that is when I started in this business quite a few years ago, Chinese companies would tell you, we do not invest in mines or deposits, only producing entities, or even further down where they're refining or fabricating. We don't want to take the risk of mines. In the last 2 years, the new president of China has completely turned this policy around. They are aggressively chasing deposits, junior entities which don't produce anything for developing deposits. It's a whole new world, and like you say, the Chinese companies looking at Ivanhoe for that deposit. They're all over South America, Africa, Canada, mm-hmm. and trading very softly in the U.S. because they feel that the U.S. does not want, the Chinese people have told me, the U.S. doesn't want a foreign company to own resources. I said, well, that's exactly the same as in your country. I can't buy a mine in China for a resource company. Well, that's different, they say. No, it isn't. And the United States is not forbidding it. It's vetting every situation like that. Mm-hmm. You have the Foreign Investment Review Board in U.S., Canada, and Australia has to review such things. You'll note that even in the last few days, a Chinese nickel company has made a substantial investment in an undeveloped deposit of rare earths in Australia. And Chinese companies already own iron mines in Australia, gold mines. These guys, it's not about what they might do. They're already doing it. And keep in mind, if the Chinese buy a deposit or a mine, that material they want to take back to China. Now, you're going to have Canadian workers or American workers, but the material that we need will go to China because they will own that material. I'm not making a political statement. I'm making a financial statement. Mm-hmm. If we don't develop these things, the Chinese need the goods. We have been hogging all this stuff, these critical materials, the platinum group metals, for years. And, as if we're we're entitled. The Chinese want these materials. They understand the system. They will buy them, and they're just beginning now in China to see a stream of scrap from catalytic converters. They're currently recycling in China in big copper smelters, which China uses 40% of the world's copper. They have a lot of that, but that's very expensive and energy intensive. And if you don't make any copper, you don't make any platinum metal. That's the beauty of the NOV.V process. Mm-hmm. You don't need to worry about you're not making copper, you're recovering platinum. And so you're independent of base metal moves. You don't shut down a smelter because there's no business for the base metal, and then you don't get the platinum. In this case, the platinum will be coming through very heavy.
Mm-hmm. And with and you touched on the mining, and I think that's important for the viewers. In 2014 to summer, beginning of 2014 to summer of 2014, there was a 6-month mine strike in South Africa, and it's settled now, but can we expect further problems? And also, these PGM miners in South Africa are being bled dry by unions, higher costs, and lower metal prices. Can this last at current prices?
Well, that's absolutely true. I don't know if you've ever visited a platinum mine or a PGM mine in Africa. Some of them are the deepest worked mines for any metal in the world. Men don't go down there in the morning and then come up in the evening. You go down for a week or 2 weeks at a time because those tunnels are so deep. They need to be air conditioned, and men literally live down there. Now, if those mines were in Quebec or Ontario or Colorado, those men would be making top dollar. But as you can guess, miners in South Africa, it's a good job, but they're not being paid anywhere near what you would pay them in a flat world where their pay was based on risk and merit. So the workers are very unhappy. As they get more educated and more aware of the world, they're finding out that they're underpaid. Well, it's extremely expensive to produce platinum, for example, in South Africa. The miners do not want a giant labor cost increase, so they're fighting this. And one of the problem we have here is that the Republic of South Africa and Zambia and Zimbabwe, none of these countries are synonymous with political stability at this point. So you can imagine the worry in the car company in Detroit or in Leeds or in Paris or Tokyo or Beijing, because they don't know if they'll be producing new platinum. So the drive is on worldwide to recycle every bit of it you can, because there's now political instability added to every other problem.
Are you there?
Oh, I'm sorry. Yeah, I had a minor setback. I'm sorry. Now, you also brought up a very important question or statement, actually, with the political scene. With, Obama's war on carbon emissions and then the global fight on global warming, now we have a race for fuel cell vehicles, hydrogen cars, electric vehicles that work absent of catalytic converters. Well, how will this affect future demand of PGMs?
Well, it's going to skyrocket because the fuel cells use a platinum cause catalyst. And a fuel cell doesn't use 2 grams of platinum like a car. It can use ounces. And one of the in the fuel cell industry has been the demand for platinum and palladium would skyrocket if we had mass production of vehicle fuel cells. I've seen, I think Honda or Toyota has a car that it has more than an ounce of platinum in the construction of the fuel cell. Well, even though platinum is only $1,200 or $1,400 an ounce, that's not the problem. Toyota makes 10 million vehicles a year. If the world production of new platinum is 7 million ounces, so if Toyota decided to have a 10 million car fleet, they couldn't. The simple as that. They're up against the barrier of demand. So there's always different technologies. But the current technology for fuel cells is dependent on platinum. If you're talking about a hydrogen fuel car, the filter for the hydrogen fuel car is a palladium screen. So you've got to have lots of palladium. You can't get away from the demand by changing to those technologies. You still have the same problem. A battery-powered car won't use any platinum, palladium, or rhodium. And if batteries ever get down to the cost of kilowatt where you can afford to use them in a long-range car, then that would lessen the use in vehicles. But even the most optimistic of people is looking for 10% hybrid or battery-operated cars by 2030. This year's production of cars is about 80 million units. It's estimated by 2030 production could be 150 million cars a year. So, okay, 15 million, let's say, will be fuel cell, battery, etc. And twice as many as you make today will require a catalytic converter. Where's it going to come from? I don't know, quite frankly, but I can tell you this. Nobody from now on is going to waste a milligram of platinum, palladium, or rhodium. Not a milligram.
So
we're going to conserve it all, recycle it all.
That's so Novx necessarily their process is coming in at the right time. And Peter brought up some good questions for us on how soon do you think that Novx 21 can complete the construction of its first 500 tons per annum plant, and how long to ramp it up to capacity?
Well, we're talking about 2016, and we don't have a definite timeline at this point. As you know, we're changing the leadership of the company. Mm-hmm. And the first year of operation will not be fully commissioned. So you're looking at 2017 for a full operating plant with 10 reactors.
Mm-hmm. Okay, that's great. And from the presentation, we had seen that the company will realize a net income at the forecast of $3 million, and that's until all the interest of the loans are paid off. So you're still realizing a profit.
That's right.
And what does the company plan to do with the profits?
This is a platform technology, Adam, so there's lots more to invest in the company.
Mm-hmm. Okay, great. So then it'll be reinvested back in the company.
Maybe Jack can talk about other applications of the technology.
So let's hear about that.
Okay. This technology works in a variety of what's called refractory metals. And so it's possible to treat lower grade ores and residues from previous minings where the concentration of the desired metal is below the level of current technology's ability to extract it. In fact, this is the next obvious use of the technology. But the fact is, you asked what are they going to do with profits? Totally reinvest them in expanding, because ultimately the company will be a central place for recovering precious materials in low-grade matrices, in which today's other technologies cannot get at them. So
that's astounding.
There is a whole lot of above-ground residues from, I hate to say it, gold mining, things like that, where even though you'd think they've got every bit of it out, they haven't. And metals like tungsten, molybdenum, all of these will work with this process. And so I see nothing but expansion here, and I suspect that the profits will be reinvested consistently here. This company has a long way to go. I can't imagine this being saturated. The world, and we've used up the high-grade deposits of almost everything this world. We've had a wonderful century that just using things and throwing them away. That's over. What's left is scrap and lower-grade ores, which require much more capital expense to extract, until you have an innovation like the Novx process, which suddenly reduces the cost of treating low-grade ores. So believe me, people are already looking at this. Companies focused on platinum group metals, but getting quite a few calls about other things where it's obvious to chemical engineers that this works. This is cool.
So, that's great. So generally, we have the company really coming in at three fronts here. We got three bullish fronts coming in. We got the PGM demand outstripping supply for future higher prices. We have growing demand for the war on pollution, especially with China, as you were saying earlier, and the emerging markets for pollution. And then we also have for capital-intensive companies to be less abrasive on the global environment. There's the war on emissions. So this company is really coming in at the right time to really get a critical metal that we need for rising demand. And generally what you were saying about the fuel cells, the cleaner the vehicle, the more PGMs are involved.
Yes, that's right.
That's great. That is great. Well, Jack Lifton, it was a pleasure to have you. I greatly appreciate you coming and speaking with me, and thank you, Nicole, for also setting this meeting up, and Peter for joining us.
Yes, thank you.
Adam. We'll talk to you soon. Thank you.
Great. Thank you, everyone.
Okay. Bye.
Bye-bye.